it's very important to do annual PM services to your heaters. The first thing that we do when we do a PM is we get on site and we're going to look at the condition of the stack. If there's soot buildup on the stack, if there's smoke coming from the burner through the stack, we're going to look at the skid itself, so the anchor bolts for the skid. If there's any cracking on the insulation of your heater itself, so the caulking, or if you see any leaks underneath. So if we look at the skid and we see some leaks, you're going to do a visual of the sight glass and look at how much glycol is actually in the unit right now. The solar panel, so the orientation of the solar panel compared to, wherever you're at, latitude, longitude. So we're going to look at the flame arrestor. We'll pull out the flame arrestor and look for debris. Depending on where the heater is located, you get a lot of debris coming in through the flame arrestor. We'll blow that out, so you blow compressed air backwards. We're going to pull the burner if that's required. We'll look inside the fire tube, see how much soot built up is inside the fire tube. So if you look at the stack cap and there's a lot of soot buildup, then you know there's going to be soot inside the fire tube. And then same thing, so you can pull off the stack cap on the back there and look to see how much debris is down there too. So anytime we see a lot of debris, that we know that the burner is running really rich and we're losing a lot of that efficiency in there inside the fire tube. It's not burning, it's just going out through the stack. And then we look at the pilot. So one of the most important things, I think, is having a very strong pilot, especially come winter time. So when it comes winter time and you have to build a really strong draft. Again, we have a lot of cold air inside the fire tube and in the stack. We need a very, very strong pilot. So the orientation of your igniter rod and then the orientation of the pilot nozzle to the end of the burner is very, very important. So what ends up happening is when the burner transitions on, it's going to want to rob air inside that fire tube, and it's going to want to pull the pilot towards itself. So if you have your burner on, the actual pilot flame, it's going to want to pull it towards itself. So depending on where your igniter rod is or your thermocouple is, depending on what you have, it's going to want to pull it away. So if that igniter rod doesn't see a flame for a fraction of a second, our system will shut it down. So on a relighter, it would attempt another relight depending on how many numbers it's already relit. So we look at the actual igniter rod and make sure you have a good connection on your igniter wire and all your connections on the igniter rod. Look and see if it's brittle. We can replace that. We can adjust it. We can pull and see what kind of a spark the igniter rod has too. So having a really, really good spark inside there is also going to make your transition better too coming on. Pilot with the Bezo system. So a Bezo, this would be with a thermocouple. The position of the thermocouple. So if the thermocouple is bathed inside the flame of the pilot is very, very important. We can check that. We can check the voltage coming from the pilot for the thermocouple, so we can actually see if your thermocouple is getting weaker. We can replace it, obviously, and then check the Bezo itself to make sure your Bezo is actually opening and gas is flowing through. So efficiency as well. So the importance of doing annual tuning of the burner itself is that in the summer and winter time, you're going to have obviously drastically different ambient conditions, which is going to have a different efficiency on the burner itself. So in the winter time, you're going to have a lot more O2, a lot more cold, dense air in there, and we're going to back off some of our O2. We'll close off our main air mixer, and you're going to get a lot better efficiency on the burner itself. It's also important to, again, with timing, so the speed control timing on your burner, so how quick that burner pressure goes from 0 to 5 psi is very, very important. Again, we're building a draft in the wintertime, so we want to build nice warm air going through the fire tube, pulling from the arrestor and then pushing that cold, dense air out of the stack. So what ends up happening is that, as things get cold and change, it starts to ramp up faster. So your speed control, these are mechanical devices, so we'll start to open up faster. So we need to make adjustments on that. And having, like I said, a very nice, smooth transition will keep the end user from call outs or things like that in the wintertime. We're going to check all the safeties when we do a PM too. So your level switch safeties, relight safeties, again with your pilot, make sure it's relighting properly and it's relighting nice and good. Your high bath temp. So your high bath temp is, again, a safety. So if your bath gets too hot, that's your Kimray or a thermocouple or something like that. And then we're going to check stack guards, depending if you have stacks, so stack temperatures. There's pilot guards as well. And then your temperature control valve, so your actual valve that toggles your main burner on and off. Check for debris inside there. Check its transitioning, so if it's coming on nice and smooth and things like that too. Check all your gauges, make sure your gauges are reading proper. But yeah, I would say the number one thing is doing tuning of the pilot and things like that too again. And then your emissions. So your summer, winter emissions is very, very important to actually do different tuning for winter and summer, just so you get better efficiency, smoother transitions, and then just reliability over time.